Question number 14 for this topic of work power energy for M1. The question statement is AB and BC are straight roads inclined at 5 degree to the horizontal and 1 degree to the horizontal respectively. A and C are the same horizontal levels and B is 45 meter above the level of C and A, as shown in the diagram. A car of mass 1200 kg travels from A to C passing through B. First part, find the motion from A to B. The speed of the car is constant and the work done against the resistance is 360 kilojoules. Find the work done by the car engine from A to B. Since B is 45 meter above A and C level, where it is making an angle of 5 degree and 1 degree to the horizontal, and work done by the resistive force is 360 kilojoules from A to B. So which we can write thing as 360 into 1000 joules. We know we have a famous equation here that work done by the driving force minus work done by the frictional force is equal to change in kinetic energy of the system plus potential energy because it is moving upward from that motion there. So let's say this is height which is 45 meter. So this velocity is constant. So this portion will be equal to 0 because speed is constant there. So work done by driving force minus work done by frictional force is equal to mgh. So work done by driving force will be equal to work done by friction plus mgh. And this work done by frictional force is given there equal to 360,000 plus mass of that particle is 1200 into g is 10 into height is 45 meters. And this value will be equal to so that value is 900,000 joules. So this is the work done by the driving force of that car when it travels from A to B at a height of 45 meter above the ground. Now we are starting the second part of this. The resistance to the motion is constant throughout the whole journey. Part 2. For this motion from B to C, the work done by the driving force is 1660 kilojoules. Given that the speed of the car is at B is 15 meters per second, show that the speed at C is 29.9 meters per second. Now we are starting the second part. Again, now the work done from the resistive force is 360 kilojoules, which is constant. And now you are finding from the work done by the driving force, which is 1660 kilojoules, and that is equal to 1600 joules. And we are going to find out the initial speed at the car A there, velocity at B is 15 meter per second. And you are going to find out the velocity at C, which is, they have shown it as 29.9 meters per second. This we have to show. So when the car is moving from B to C, we know that the work done by the resistive force is basically equal to the resistive force into velocity into the distance. So for this particle B there, we will calculate the speed, and work done by the resistive force is given there 36000, because it is remaining same there, and the resistive force into D. But we know that in this triangle ABD, it is making an angle of 5 degree, and this is 45 meter above D point there. Let's say this distance is D is being calculated in this part. So we can write it like this, that 45 over D is equal to sine of 5, or D is equal to 45 over sine of 5. One thing we know it further there, that this resistive force is basically equal to 360,000 divided by 45 over sine of 5 at the point B. Now, it is moving towards C, which is inclined at 1 degree to the horizontal. So, again, we have this right angle triangle there, which is making an angle of 1 degree to that. It is 45 meter high, and let's say this distance is D1. So, we can calculate 45 over D1 is equal to sine of 1 degree, or D1 is equal to 45 over sine of 1 degree. Now we will calculate the total work done from B to C there. For the resistive force, the resistive force is already being calculated equal to this divided by 45 over sine of 5 multiplied by the distance D1, that is equal to 45 over sine of 1, and work done by the resistive force from B to C is equal to so this value is being calculated there 1797807.5 joules. Now, as it moved from B to C, so we know that work done by driving force minus work done by frictional force is equal to change in kinetic energy of the system, because it is getting downward, so potential energy will be lost there, and it will be written as mgh there. So half m V square we don't know. U square is 15 square is equal to work done by driving force minus work done by frictional force plus mgh. And now you will put the values into this. Work done by driving force is 16000 minus work done by the frictional force is equal to 1797807.5 plus m, that is mass of that car is 1200, g is 10, and the height is 45. So this value is being calculated there equal to. So this value is being calculated there 402192. Now half mass is there 1200 into v square minus 15 square is equal to 402192. So v square minus 225 is equal to 402192 divided by 600, and that value is equal to 670.3. So v square is equal to 225 plus 670.3. It is 895.3. So v value is the square root of 895.3. So it is 29.9 meter per second. V at c. This is the value which we are going to calculate in this part. And we have to show that the velocity at c is equal to 29.9 meters per second. But in this case, we first have to resolve this resultant force of the resistive force into the components. First find the total driving force for that part, and then you can find out the displacement of that, and then you will calculate this v square. Now the last part of this. The car's driving force immediately after leaving B is 1.5 times the driving force immediately before leaving C. Find, correct to the two significant figures, the ratio of the power developed by the car engine immediately after leaving B to the immediately after leaving A there. So we have to get the ratio between power at B to the power at C, but it is 1.5 times of the power of B to the power at C. So this will be equal to 1.5 into power at B is the driving force into velocity at B divided by driving force of C into the velocity at C. So this will be equal to 1.5 into the driving force at B velocity at B is there 15 and at C there is 29.9. So this at B. So this and this calculation will be cancelled. So finally it will be left equal to 1.5 into 15 over 29.9, and this value is equal to 0.75. So this is the ratio of this power at B to the power at C. We know that the power is basically equal to driving force into velocity, but driving force at C is 1.5 times of that. So we can write it like 1.5 driving force at B and driving force at C, which is being calculated equal to B there. And that thing is being cancelled out. And finally, this calculation is 0.75. So this is the complete solution for this question number 14 with all parts.